Welcome to the Destiny of Manufacturing podcast, and we are live here from the show floor at FABTECH 2025 at the PMA booth, of course. It is great to have with me. I have Lew Hurlbert here from Vollrath, who is the Senior Engineering Manager. It is great to have you, Lew. We've been trying to get you on this show for at least a year and a half or more now.
Right. Yeah. No, it's just a real thrill to finally connect and be able to do this.
It is fantastic.
Yep.
We love to tap into your knowledge and your experiences that you've had over the years. And that's really important because that's what we want to convey to people is that, you know, at PMA, one of the most important things is our association and the network and communicating it. How do we get our message out to people? Because there's a lot of really interesting things going on. Let's talk about some of the technology things that you're excited about.
Yeah. No, and thank you for having me here. I mean, is this FABTECH such a great show? Seeing all the young people here, all the participation. I mean, it's really an exciting time. I mean, in this year to see so many additional people here, it's great, just fabulous. So let me lead right into, let's talk about AI, right? It is the big pressing thing. It's the big question that everybody asks, where is this going to take us and what is it going to turn into for us, you know, as die makers? So where does the die industry go in die manufacturing? And so in preparation for this, it gives me a lot more time of reflection to say, you know what if we look at, instead of a large language model, a large die model and what that would entail? And so you think about the Internet of Things, but then there's also this internal network of tool shops and stuff that would be required in order to feed a system like that.
Right.
Because an AI needs data. So it's how does all that information come and how does all those things collaborate in order for this to become intuitive, become adaptive in order to go and guide what a process would entail.
Right.
So I think that, you know, looking on, you know, some past experiences and seeing where simulation was, you know, my past career at Chrysler, and we developed simulation. We developed the draw simulation in the years and the work that it took and all the people involved. It was just to do the formability to get to an FLD safe product. Right.
Mm-hmm.
But it's that feedback loop and what it takes in order to get things back in and through in order to then refine the software, come up with the accuracy of it, you know. And you look at where an AI is and you look at where our softwares are today, and there's now getting to be more compatibility between softwares. Not a plug for anybody, but if you take a SolidWorks and a logo press, you can load a part in, you can do an unwrap. And if you have your model set up properly, all your components, your library, the tool will start to develop and design itself.
Right.
Right. So, I mean, there's that aspect of it. But what does that lack? Much like I referenced within the simulation, it doesn't get that feedback. But what I would propose is you consider 5 years out and what it's going to take, you know, through a network of probably higher end complex die manufacturers to work within these systems to feed products and like products so that the AI can then become more adaptive to say, okay, if we're going to do a B pillar, XYZ product doesn't matter, just what's the next one like it? And how do we do that previous one? What was the result? How do you refine it? So it becomes like a PDCA feedback loop for how that can develop. So I expect more things to get further into with AI when you consider on the competitive aspects. If we can put into the system, the product, the software will design it, you can get your design validation steps where your first gate, classic stage gate process, right? Is this design robust? Is the process approved? Does this produce a good panel? Yes. Okay, go.
Yeah.
Fire up and go. Now you go into your build. Well, your build then, AI should be able to drive us to that interconnectivity within shops. I mean, we've had print-free die shops for 2 decades now. So what are we working off? We're working off the same CAD model that AI is going to be driving and doing that. Create your software, your tool paths, your setups, your die process activities, right? In order to get to a build and a validation step. So is it built? How does that go? Go to the bench, take that right to the press, right? So you're at that next part of, okay, let's go in and prove it out. Let's prove and see what that does.
Right.
But I think that carrying things through in a larger concept, right, is program management. Program management is the thing that drives all of us to say, how can we be competitive in the workplace? How do we be competitive in a global environment,
Right.
right? It's speed to market in terms of what your product development activities are and your most effective cost and what it takes to produce.
Right.
So there's a lot of huge benefits, I think, as to what the AI is going to do. But I think that final stage, which is where nothing has gone to yet, is to truly see the simulation of the press, the dynamic environment of what's going on,
Right.
the run it rate, what your part drop is, what your scrap file is, what your pass line windows are. I mean, if you get into your multi-axis, your transfer, crossbar, tandem, give whatever you want to throw at it, let all these things in the AI and the simulation go and prove that out. Now you get rid of crashes, your late engineering modifications. So your time to market becomes so much faster and you're becoming very cost effective, very competitive in
Right.
such a dynamic world.
Yeah. And I think that it's interesting you talk about that, because one of the things that I always see is people, and I mentioned this yesterday, we were talking to the tool and die division, and one of the things that came up was people will say, well, the run rate is 30 strokes per minute on this. But there's a difference between a 30 stroke per minute press running at 8-inch stroke, one running at 12 and one running at 24. And you're going to tell me that 30 strokes per minute is the same. The slide velocities are not the same. Right?
It's got to go that much faster to get there. Right?
That's right. And that's going to make an impact on whether material will be able to flow. Will it tear the material? All of those things that you have to be able to know to feed back into that model, because that model can't be a static model. It has to be dynamic.
Right. It's truly a dynamic model. Absolutely. And I think with, the background within complex draws and deep drawn products, when you look at all the additional press parameters, as opposed to just setting a stroke or just setting a tonnage, there's so many other parameters that come into play. Again, referencing back to the days of simulation, we had the University of Michigan come in and they're doing photogrammetry studies looking at press, ram, and bed deflection. Right. We're looking at the dynamic movements that are going on inside of the tool. As much as we all think and see this is solid element tooling and guessing, it's not. There is deflection. There is movement.
Yep.
Those are the things that, as die makers, we're left wondering, well, I set this right on the bench. Why is it acting this way? When you're in there doing your validation, it's that dynamic aspect of which we all work in. Something's moving that wasn't quite anticipated, that was caught in the sim.
Yeah.
Again, goes back to the AI. That end result feedback coming in just helps us go and refine what its potential is. It can give you better solutions, or it may drive you, think of it this way as you carry this conversation. This is good talk. What about if we go to a different press? What does that result give me? Can I get a better feed rate? Can I hit a price target? Because at the end of the day, your production sources, they've got to hit a price point in order to land that business, in order to keep that business.
Right.
Or in a case of, go even further, the cost down expectations go on year over year. Now you're starting to look at how do you refine and what that optimization looks like. Run it back through the AI and see where you're at.
Yeah, that's excellent. Lew, we're out of time here, but thank you so much for coming by. This has been the Destiny of Manufacturing podcast. I'm your host, Dean Phillips, and it has been great to have Lew Hurlbert here with me. It has always been my pleasure, sir, and thank you for stopping by.
Thank you very much. Real pleasure.